Hello everyone, welcome to Pay One Tech Media. In this video we will talk about VLSM, Variable Length Subnet Mask. So in previous videos we talked about IP version for different classes, class A, B, C, D and E, and we talked about mainly we do have for class A, B and C, we do have a default subnet mask. We talked about subnetting, breaking large network into the smaller networks. We talked about supernetting, combining multiple subnets, smaller networks, into one big large network. And now when we talk about VLSM, the variable length subnet mask, specifically when we talked about subnetting previously, so we did break a large network into the smaller subnetworks, but these smaller subnetworks, they were pretty much fixed length. All of the subnetworks, they had same amount of computers, same amount of available IP addresses per subnet. But let's say you might want to break a large network into the smaller networks, but in one of the subnetworks you might want, let's say, 50 computers. In another subnetworks you might want, let's say, 10 available IP addresses, or for 10 computers. Another subnet, let's say you might want 20 available IP addresses. So that's where VLSM comes into play. The variable length subnet mask gives us the availability to break a large network into the smaller subnetworks, but with different variable length subnets, with different basically amounts of available IP addresses per subnet. Not all the subnets having the same numbers of available IP addresses. So stay tuned, let's jump into my computer and take a look. The subnetting, when we did break the large network into the smaller networks, all of them, it was kind of like fixed length subnets. So for example, to show you a quick recap of the subnetting, so we talked about if we had this network address of 192.168.1.0 with the side notation of, let's say, 28. We know this is not the default subnet mask because this address is class C network address. The 192, that's class C. And for class C default subnet mask is the SADA notation of 24. This is the SADA notation of 28. So in the previous videos we talked about a lot more in detail. If you haven't watched, please make sure to watch those videos. So with the SADA notation of the 28, if we count left to right, this is 8 plus 8, 16, plus 8, 24, 25, 26, 27, and 28. So this is our cut line. The original cut line was here, moved it to the right. That's subnetting, right? We talked about previously. Anytime when we move the cut line to the right, it's subnetting, breaking a large network into the smaller network, and all these ones will be our subnet bits we borrowed from the host bits, and the rest of them, it's the host bits, all zeros. And of course all here, it's ones, our network bits. So in this case we have 28 ones, all network bits, and the last one that is turned on, 16, is our network increment. So it's basically we will have multiple subnets incrementing by 16. And again, if we want to quickly find out the number of subnets going from left to right, starting with 2, 4, 8, 16, gives us 16 subnets. Number of hosts going from right to left, starting with 2, 4, 8, 16 minus 2, 14. And every subnet will give us 14 available IP addresses. 16 number of subnets, and every subnet 14 available IP addresses. But let's say we don't want the number of available IP addresses be fixed for every subnet. That's where VLSM comes into play. And in what scenario we don't want all the subnets be fixed? For example, let's say if we have point-to-point connections. Let's say if we have 3 different routers, and here, these are the point-to-point connections. If this is router 1, router 2, router 3, and these are the networks. So here we have one network here, 2, 3, and of course the point-to-point connections, 4 and 5 networks. So in this network, it's only 2 IP addresses we need, and this network only 2 IP addresses we need. If we go by fixed length subnet mask, we will have 14 available IP addresses per subnet. But for the point-to-point networks, we only need 2. So that's where the VLSM comes into play. You might say, yes, we could go with the SADO notation of 30, which gives us a total of available 2 IP addresses, and we can use it point-to-point. But if we go by fixed length subnet mask, every subnet we will have 2 IP addresses. Okay, let's go over one example of VLSM now. Let's say we have this network of 3 different routers where we have multiple different networks. And let's say for this one we need 100 available IP addresses. This one, let's say we need 50. And this one, let's say we need only 10 available IP addresses. And this one we need only 2 because of the point-to-point connections. And if we want to count the number of networks, so this is 1 network, 2, 3, 4, and 5. We can say if this is network A, network B, network C, network D, and network E. So what we need to do first, we have to start with the largest network, network A. We need 100 available IP addresses. Network B, we need 50, and network C, we need only 10. Network D, 2, and network E, also 2 available. And please do not confuse this with the IPv4 classes, where we have 5 different classes, class A, B, C, D, E. These are just, I assigned A, B, C, D, E for these networks. Here we are talking about, let's say if this is the name of network A, network B, network C, not classes. Okay, so when we talk about VLSM, we have to start from the largest first. And let's say the network address they gave us, 192.168.1.0 network with the default SADA notation of 24, which we know this is class C, 255.255.255.0. That's the default subnet mask for class C. 24 bits turned on. 8 plus 8, 16 plus 8, 24. So all this section here is the network section, this section, the host section, which we have 8 zeros and 24 ones. Okay, now here we can see they said 100, 50, 10, 2, 2, right? So that's total of 164, which we know default subnet mask class C gives us 254, so that's more than enough for all these subnets. We should have all the subnets with the correct amount of available IP addresses. Let's see. So for network A, we need 100. And as we talked about previously, the number of available IP addresses we can count right to left with number of 2, 2, 4, 8, 16, 32, 64, 128. We can stop here. Very good. Because 128 minus 2, 126. And they are asking for 100, which it's more than enough. 126, it covers all the 100. So that's our first SADA notation. Therefore, for this one, starting with the 0 network, we have 192.168.1.0 with the SADA notation of 25, because up to here is 24 plus this one 25, right? The cut line is here now, which the subnet mask is 255.255.255, and here it's only 128 turned on, which is 128. So if I erase this, so the increment is 128. Therefore, next subnet is 192.168.1.128. Okay, now this one is 50. So if we count 2, 4, 8, 16, 32, 64, very good, 64 minus 2. If I erase this section here, $62 Very good. Now the cut line is here. So let's erase this. And the increment is 64. So 192.168.128 plus 64. That's for this network. But first let's find out the CIDR notation, which is 26. Which when we increment 128 plus 64, that's 192. So in other words, the range 0 to 128, that's for network A, which they needed 100. And the range from 128 to 192, that's for network B, they needed only 50. It covers that in this range. Now for network C, they need only 10. So 2, 4, 8, 16 minus 2, 14. Very good. So the cut line here should be good. And let's erase all this. Now the last bit turned on is 16. So increment 192 plus 16, which is 208. So it is 192, 168, 1.208. Okay, so what is the CIDR notation for this? If we count 8 plus 8, 16 plus 8, 24, 25, 26, 27, 28. And for network D, they needed 2. That's point to point right here, network D. One IP address here, one IP address here. Let's say connecting router 1 to router 2. And then if this is router 3. Okay, so we need only 2 available IP addresses. Again, counting, going from right to left. Number of hosts, 2, 4. 4 is good. Minus 2 is 2. So we can stop here. Let's erase all this. And now the last bit that is turned on is 4. It's incrementing by 4. So 208 plus 4, 192, 168, 1.208 plus 4, that's 212. Now what is the CIDR notation for network D? Let's count. So here we have 8 plus 8, 16 plus 8, 24, 25, 26, 27, 28, 29, 30. So with the CIDR notation of 30 gives us 2 available IP addresses. Here they need for network E. Here network E. Again, same, 2 available IP addresses, so that's also 30. Therefore, increment 192, 168, 1 dot, incrementing by 4 to 16. So this is the first subnet, the second subnet, the third, fourth, and the fifth. The first one for network A, 192.168.1.0. For this one, let's write down 192.168.1.0 with the CIDR notation of 25, which 25 gives us subnet mask of 255.255.255.128, because 25 bits turned on. If we count left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on, up to here 24. 25 here, and draw a cut line, the rest of them 0, so 128, only 128. For the other network, the address is 192.168.1.128 with the CIDR notation of 26, and the subnet mask is 255.255.255.192. because the cut line is here now, so 128 plus 64 is 192 with the 26. So 28 for C, this one, network address 192.168.1.192, and the subnet mask 255.255.255.240. Why 240? Because here for network C, they needed 10 IP addresses, right? So if we count 2, 4, 8, 16, and draw a cut line, 16 minus 2, 14. So 14, that's more than enough. It covers the 10. It provides more than what we need. We're not wasting too many IP addresses. And if the cut line is here, so we have up to here number of ones, the rest of them it's 0. So we have 4 ones and 4 zeros. So 128 plus 64, 192, plus 32, 224, plus 16, 240. So if the cut line is here, is 240 here. And of course, the side notation, if the cut line is here, 8 plus 8, 16 plus 8, 24, 25, 26, 27, 28. And for this network, as per much, we can use this one for network D, 192.168.1.208. The side notation 30. And if the side notation is 30, the subnet mask is 255.255.255.252. Because here, cut line, only these two, and decimal values 3, 252 plus 3, 255. And for this one would be 192.168.1.212. Same thing, 255.255.255.252. So for example, for this IP address, 208 is the network address, so 209, 209, and for here, 210. And then 211, that's the broadcast for this network, and 212, that's the next network. So for this one would be 213, and here 214, and 215 would be the broadcast for this subnet, and 216 is the next subnetwork. So here, it's basically kind of similar to the subnetting, breaking a large network into the multiple smaller network, but it's not fixed length subnet mask. It's pretty much variable length subnet mask. We will have different subnet masks, as we can see here, per subnet. And it gives us different number of available IP addresses per subnet. This way, we don't waste too many IP addresses, and it is more organized and manageable. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again and have a good day.